Hello, my name is Jake DeVos, and this is my presentation on visual conceptions of the Earth-Moon system, also called EMS. You'll hear me referring to it as EMS throughout the presentation here, so just be aware of that. That's the Earth-Moon system. The research article I studied was the diagrammatic representational constraints of spatial scale and Earth-Moon system astronomy instruction. The authors are Roger S. Taylor and Erica D. Grunstrom. So why astronomy? Well, I am going to be an Earth Science, Earth Systems teacher next year, and I'm a little bit nervous. I'm a little bit unfamiliar with a lot of these topics, and especially astronomy, so I wanted to do this research in astronomy, especially when it comes to visual literacy of astronomy. There are a lot of visual aids that you can use inside of astronomy that have potential dangers. For instance, you could get an incorrect scale, which is what this research is going to go over, just by looking at a picture of the Earth and Moon side by side. You don't know what images you can trust online with there being such a vast amount of images out there. And there's some that just look visually attractive, just fantastic images that I would want to put up there, but that's very dangerous because students are generating ideas. They're generating scale models and schema based off of images that you put up there. They are learning. You can't just tell them to stop learning. So with this picture here, they may think that the sun is not as big as what we thought it was. I mean, that's what they maybe previously learned. So just potential dangers you got to look out for, which is going to be talked about in this research article. So the research question is, do the visual constraints of print and digital media influence the instruction of spatial scale? So when it comes to anything on print, just a piece of paper, a textbook, or digital media being online, how does it influence my students' understanding or my instruction of spatial scale? Am I teaching them things that I didn't know, right? How is it influencing the instruction? So scales of what? Well, we have scales of distance and size. So here's the first image that showed up on Google when I looked up Earth and Moon. So we have a couple scales going on here. We have the scale of distance, how far away is the Moon from the Earth, and we have the scale of size, how big is the Moon compared to how big the Earth is. Is that accurate? Is it inaccurate? Could I put this up in my class when talking about this? Would this misguide them, right? Well, here's the second image that showed up, and oh my gosh, here we go. It's a completely different a size here anyway than before. The distance is a little bit longer, but I mean it's basically the same. And but the size here is much different. So which one's correct? Which one can we trust, right? That's what this research article is going to go into. And here's those images side by side. Which one's correct? Which one can we trust, right? So here is the correct ratios of size and distance when we're comparing the Earth and the Moon. So the Earth's width diameter is approximately 4 times larger than that of the Moon. And the distance, the Moon is approximately 30 Earth diameters away from the Earth. So here, if we're looking at size, the picture here to the left does look like you can fit 4 diameters of the Moon inside the Earth. The picture to the right looks like you cannot fit 4 diameters of the Moon. That's more like a 2-to-1 ratio. The one to the left is a 4-to-1 ratio, which is what it should be. The one to the right is too large. The Moon is too large compared to the Earth there. Now, the distance, as we just read, you should be able to fit 30 Earths in between the Earth and the Moon, and neither one of these are anywhere near close, but we wouldn't have known that unless we brought that up. So it's very important that you bring this stuff up in class as well. Okay, so those are the real ones. Then on a piece of paper, what can we put on a piece of paper is the question here. What is even plausible to put on a piece? Is it possible to put a representation of the Earth and the Moon on a piece of paper if I had to fit 30 Earths in between the two, right? Well, the smallest dot that can be seen on a piece of paper has a diameter of 0.8 millimeters. So we're going to use that as our moon. Right? And if I have to fit, if 4 moons can fit inside of Earth, then 0.8 times 4 is 3.2 millimeters. And the distance between Earth and Moon, so that I can fit 30 Earths in between the two, so that's going to be 3.2 times 30, which is 96 millimeters. So can I fit this on a piece of paper? I have a size limit on my paper of 165 millimeters, so yes, I can fit this on a piece of paper. So why do we see this? Why is this a typical example that we would see inside of in a textbook, right? Why would we see this instead of seeing something like this? Now, it takes a little second here, but to the left you see Earth, to the right you see the Moon. Why don't we see more of this? This is drawn to scale. I can fit 4 diameters of the Moon inside of the diameter of the Earth there, and I can fit 30 Earths in between the two here. This is simple enough. You can fit on a piece of paper. Why don't we see it? What do the students see? Well, we see 2 sources for scale. They have textbooks and they have the internet. That's what our research is really going to focus on here is textbooks and the internet, and the pictures that they'll see, the visuals they'll see in textbooks and the internet. And so our method, how are we going to determine whether or not those 2 types of sources are affecting our students' understanding. So this study examined the diagrammatic representations of the EMS produced by 6th grade students, middle school science textbooks, and science education information retrieved from the web. So we have 35 6th grade students drawn representation. So they're going to just draw out their own representation of the distance between the Earth and the Moon and the size and distance scales, right? We have 30 images from 8 middle school textbooks and 45 images from educational governmental websites. So 2 ratios to consider. We have size and we have distance. Size, we're going to be looking at the 3 portions here: student estimates, textbook images, and web images. So size and distance we're looking at first. We're going to look at our results for just size and what we got for each of these 3. So for student estimates, they were significantly below correct value. Students thought the moon was twice as large as actual size. So the ratios were below the correct value. The size ratio for textbook images was also significantly below correct value. Textbooks thought the moon was 1.5 times larger than the actual size. And last one for size ratio, we have web images. They were also significantly below correct value. The moon was larger than it actually is. 7 web images had the sizes of the Earth and the moon to be nearly equal. There were 3 images that had the size of the moon 6 to 12 times smaller than the size of the Earth. So here we can see our size ratio depicted in a diagram here. We have students ratio, textbook ratios, and web ratio. There's a dotted line towards the center of these. That's going to be the actual size ratio. It should be around 3.6. As we can tell, they were all below. So every single student, textbook, and web, they all seem to be below that size, the correct size ratio. And this is about a 1 to 2. All the ratios here on this graph were about a 1 to 2 ratio in diameter. So maybe that's a good indicator of why we got that incorrectly stated. So our second scale is going to be distance. Remember, the actual distance is 30 Earths between the Earth and the Moon. So we'll look at student estimates, textbook images, and web images again for distance. Now we're looking at distance ratio. So here the ratio for student estimates were significantly below correct value. Students think the moon is 16 times closer to the Earth than it actually is. So that is a big difference here. The distance ratio for textbook images significantly below correct value again. Textbooks depict the moon as being 23 times closer than it actually is. The distance here for web images, the ratio was significantly below correct value. Web images were 14 times closer than the actual distance between the Earth and the moon. So here, the dotted line is much higher up now. That's going to be our actual ratio. It should be 30. And a 30-to-1 ratio, right? And everywhere, the web, the textbook, and the students were all very, very low, in between 0 and 5 typically. So big problems here. Advice from researchers: when possible, include an accurate visual representation of the Earth-Moon system, or just accurate visuals in general. And when such representations are not useful or feasible, include an embedded not-to-scale warning figure caption next indicating the correct size and distance ratios. So we have a, according to our data here, we have a very obvious miscommunication of information by using these visuals. Our textbooks and our webs are absolutely along that same distance ratio as what our students are learning, which is nowhere near our actual, which should be closer to top here at 30. So for my classroom, I want to do projects where students are discovering this exact problem. I want my students to discover this problem with looking at visuals, ratios not being correct, and the implications of that. So I want them to figure that out for themselves, and not be afraid of this. I want them to see that, so that when this comes up in real life as well, when they're just doing research on their own, that they are aware of the potential dangers here. I want to teach learners how to scale things for themselves. Scale it. Teach them about ratios. Make sure that they are very in-depth in knowledge on ratios, and I also want to practice what I preach. I want to use accurate diagrams and have actual dimensions labeled if accuracy is not realistic. These are my citations, and I learned a lot. Thank you so much for paying attention and listening, and have a wonderful day.